Okay, I'm going to go over quiz S.5a with the confidence intervals and margin of error. And students usually do well on this one. It's just remembering the vocabulary is the trick for this one. Question 1, a poll was conducted about an upcoming election. The results are considered accurate within plus or minus 4% points or percentage points 9 times out of 10. State the confidence level. So the confidence level is how confident are you about this result. So it's 9 out of 10, which is 90%. I'm 90% sure that this answers whatever the result is right. Question 2, the results of a survey have a confidence interval of 29% to 37%, 9 times out of 10. Determine the margin of error. So the margin of error is going to be half of the distance between these two. So it's going to be 37 minus 29 divided by 2, which is 8. Or 4, sorry, the difference is 8, so it's 4. So my confidence interval is plus or minus 4%. And it would normally be reported, for example, as 33 plus or minus 4%, right? Because 33 is the middle point between those two, not 29 and 37%. Question 3, a poll was conducted about an upcoming election. The result that 18% of people intend to vote for one of the candidates is considered accurate within plus or minus 4.5% points, 9 times out of 10. State the confidence interval. So the interval is the range from the lowest number we think it is to the highest number we think it is. So it's going to be 18 minus that 4.5, which equals 13.5, and 18 plus 4.5, which is 22.5. So our confidence interval is 13.5% to 22.5%. Number 4, in a recent survey of high school students, 43% of those surveyed agreed that the lunch period should be extended. Survey is considered accurate to within 4.6% points, 19 times out of 20. If a high school has 1,500 students, state the range of the number of students who would agree with the survey. So let's do our confidence interval, first of all, in terms of percent. So confidence interval is going to be 43 minus 4.6, which is 38.4%, to 43 plus 4.6, which is 47.6%. So our confidence interval is 38.4% to 47.6%, but we need numbers. But need numbers. So I need to find what 38.44% of 1,500 is 0.384 times 1,500, which is 576, and 47.6% of 1,500, which is 0.476 times 1,500, which is 714. So my answer is it's between 576 to 714 students. Okay, is that good? Okay, next page. Question 5. Use confidence intervals to interpret the following statement and apply the result to a graduating class of 1,400 students. In a recent survey, 72% of post-secondary graduates indicated that they expect to earn at least $6,000 a month by the time they were ready to retire. The survey is considered accurate within plus or minus 5.2%, 19 times out of 20. So we're asked to interpret the statement. So that's when you're asked to interpret it, that's because that's that big sentence that you want to do. So we need to figure out what the range, what the confidence interval is. So to do that, we're going to go 72 minus 5.2 is 66.8%. And then that equals, actually I'm going to draw an arrow. So I want to change that to a number of students, not because they've given us the number of students, we need to report it in numbers, not just in percents. So 0.668 times 1400 equals 935, and then we go 72 plus 5.2, and that's 77.2%. So I'm going to go 0.772 times 1400 equals 1080.8. And I'm going to type this because my writing is just atrocious. Okay, so with 95% confidence, it can be said that 935 to 1081 of the 1400 graduates expect to earn at least $6,000 per month by the time they are ready to retire. Change that back to a lowercase t. And the calculation I didn't actually do formally was that 19 out of 20 equals 95%. That's where the 95 comes from. Okay. How could they increase the confidence level of the result? Well, there's two ways you can increase the confidence level. You can increase the sample size, or you can increase the margin of error. Okay, and how much it changes those things is beyond the scope of this course. You just need to know that those are the two things you can change, and that makes sense, right? Because if I've asked more people, I'm more confident of the results, and if I make my range, if I say between 900 and 1100, think this is true. Well, I've got more error. I've got more room to be wrong, so I can be more sure that my answers, that the correct value, the true value, is in there. Okay, question 6. A hardware supplies company takes a random sample to check the lengths of lag bolts. For a sample of 100 bolts, the mean length of the bolt is 86.5 millimeters with a margin of error of plus or minus 0.6 millimeters. The result is considered accurate 95% of the time. State the confidence interval for the mean length of the lag bolts. So it's going to be 86.5 minus 0.6, which is 85.9, and it to 86.5 plus 0.6, which is 87.1. So our answer is 85.9 to 87.1 millimeters. 3 other samples of different sizes were taken using the same confidence level as shown below, but the margin of error for each sample was mixed up. Match the correct margin of error with each sample size. Well, we know that as the sample size gets bigger, the margin of error gets smaller. So the biggest sample has to have the smallest margin of error. So that's got to be the 0.2. And then the smallest sample's got the biggest margin of error. So that's where the other two numbers have to go. Okay, that's the end of the quiz.